So lesson 8 is going to be the sum of a geometric series, and what that means is when we add together the first certain number of terms in a sequence, what is their sum? So, and we're looking at geometric, so let's look at a really simple example. 1 plus 2 plus 4 plus 8, 16. So these are the first 5 terms of the sequence, and the sum of these 5, you could add them together, that's 24, 28, 31. The sum of the first 5 terms is 31, and that's easy, you could just add them together. But what if I said find the sum of the first 50 terms? You don't want to sit there and go 32, 64, 128, and keep going and going and going, have 50 terms and add them all together. That would be pretty miserable. So instead we have a formula that's going to help us to find the sum of the first n terms, any number of terms, okay? Now, notation-wise, if you have any sequence, the first term, the second term, the third term, the fourth term, all the way up to the nth term, the sum of the first n terms, S sub n is the sum of the first n terms, equals just add together each of these numbers up to the nth term. And the notation we use is the sum of the first n terms is the sum of all the terms from 1 to n, okay? And we're working with finite sums, which means we only go up to a certain number of terms. Now, if you take a look here, to find the sum of a certain number of terms, they have this formula here, but this is really, it's equivalent, but the reference sheet uses one that's slightly different. You can see geometric series, this is what we need to find the sum of the first n terms. The reference sheet says a sub 1 minus a sub 1 times the rate to the n over 1 minus the rate. Here, it's just distributed. It's the same thing distributed. Okay, notice also these are other formulas to find the nth term, exact nth term in arithmetic or geometric. Those are formulas you get on the reference sheet. So let's look at number 1. And I just copied the formula down here, so it's going to help us out for a second. So Jasmine decides to put $100 into a savings account each month, and the account pays 3% annual interest. Now be careful with this one. This one's a little tricky because it's compounded monthly. So really, what is the rate at which we're going to multiply by each month? Well, it's not 1 plus 0.03, it's 1 plus 0.03 over 12. It's the rate compounded monthly, which comes out to 1.0025. So this is going to equal the rate which we're going to multiply $100 by each month. So now we could just plug everything into this formula. The sum of the first 12 terms is going to equal 100 minus 100 times 1.0025 raised to the 12th over 1 minus 0.0025, which is choice 2. Now keep in mind, if you want to know how much money you have to, the sum of the 12, you just add these, you just put this in the calculator. All right, so number 2. The first term of a geometric sequence is 8, and the fourth term is 216. What is the sum of the first 12 terms of this series? Well, first off, I got to find out what the ratio is we're multiplying by each time. You could do a little guess and check. You do 8 times 2, which is 64, times 2 is 128, times 2 is 250. It's not, like, you got to figure out what it is. You can. If you could do it by hand, that's fine, but I'm just going to use the formula that we have up here for a geometric sequence. So I'm going to say 216 equals the initial times the rate to the n minus 1. Well, what is n here? 4. It's the fourth term. And I could just use this and solve. So you get 216 equals 8 times r cubed. Divide by 8. You get 27 equals r cubed, and you take the cubed root, and you get r equals 3. It's multiplied by 3. And you can even see that works. 8 something something 216. So if you multiply by 3, 8, 16, 24. 24 times 3, 24, 48, 72. And then multiply by 3, 216. So that does work. So the rate is 3. So now we're going to go back and we're going to plug into our formula here. To find the sum of the first, we want 12 terms. So S sub 12 equals 8 minus 8 times 3 to the 12th over 1 minus 3. And let's just plug that in the calculator, see what we get. What is the sum of the first? It should be a pretty big number because you're adding together, multiplying 8 by 3 many times, 12, 11 more times, and adding all those numbers together. Let's see. 8 minus 8, parentheses 3, to the 12th. That numerator all divided by 1 minus 3. And you get 2,125,760, which is choice 3. Great. All right, number 3. Let's see. A ball is dropped from a height of 32 feet and bounces 80% of its height. So that's 0.8 is the rate. You multiply by 0.8, it'll tell you what the height is after a bounce, and then another bounce, and another bounce, and another bounce. So it says, what is the total downward distance in feet the ball traveled up to the 12th bounce? So let's see. The initial is 32. The rate is 0.8. And we're going to plug into our formula. So we get the sum of the first 12 is going to be 32 minus 32 times 0.8 to the 12th. This is a coincidence we keep doing 12, by the way. Over 1 minus 0.8. Put that in the calculator, and you'll get 149.004, which 149. Number 4. A 7-year lease for office space states that the annual rent is $85,000 for the first year and will increase by 6% each additional year. So if it goes up by 6%, then what you're going to multiply by is 1.06 each year. Okay, so what is the total rent you will pay in the 7 years? Well, you're going to pay $85,000 the first year, multiply that by 1.06, pay that the next year, multiply that by 1.06, pay that the next year. What are you going to pay in the entire 7 years? The sum of the first 7 terms is, formula again, it's right up there, a sub 1, 85,000 minus 85,000 times 1.067 years over 1 minus 1.06. Enter that into the calculator. You will get 4. And the last one, Brian deposited 1 cent into an empty non-interest bearing account on the first day of the month. He then additionally deposits 3 cents on the second day, 9 cents on the third day, 27 cents on the fourth day. What would be the total amount of money in the account at the end of 20 days? So what is he doing here? Well, what is he multiplying the amount he puts in each day? He's multiplying it by 3. He's taking 1 cent to 3 cents, 3 cents to 9 cents. So each day he's depositing triple what he did the day before. And I bet this is going to be, actually, I mean, look at those choices. It's going to be really big. So now we have the initial is, and be careful here, it's not 1, it's 0.01. So we get the sum of the first 20 days of putting money in is going to be 0.01 minus 0.01 times 3 to the 20th over 1 minus 3, the rate, right? All from the formula. Plug that into the calculator and you will see Brian is going to be pretty rich if he keeps this up. Choice 2. All right, try the homework out and I'll post a key later as well.